Hi, my name is Hannes. As Jeff said, I'm a machine learning engineer at Digits. I'm also a Google developer expert for machine learning, and I had the chance to co-author 3 machine learning related publications. Yeah, that is a very mindful clicker. Do you have a second one? Okay. So just a question, quick show of hands. Who is working with large language models? Okay. Who is consuming model APIs? Okay. And who is fine-tuning their LLMs? Okay. Cool, that's a good number to see. All right. So you might have, can you go back one slide, please? Okay, you might wonder what is Digits. We are not a service or a platform for machine learning. We don't have a machine learning service. We're basically consuming those tools to help accountants and business owners to do accounting and bookkeeping in real time. So that requires a lot of machine learning. We support accountants by doing things in no time by using classification models, similarity-based machine learning, et cetera, et cetera. So we basically use machine learning to take the tedium out of the bookkeeping work. Next slide, please. If you wonder about what do we do in terms of machine learning there, we do heavily production machine learning. So starting off with what we call subjective machine learning. So you can have a transaction, it says I don't know, Starbucks at a given airport. You show this to one accountant that says oh, this is a meal expense. And the next accountant will say, this is actually a travel expense because it happened at an airport. Both accountants are correct. So we have to create machine learning which supports those use cases. And so the typical classification models don't work anymore. So we came up with a system what we call subjective machine learning, lots of real-world applications. And everything is end-to-end, fully production-driven. So we have production pipelines, we have automated ML deployments, feedback loops, and we also deploy models like Llama 2 in production. So for today, I want to talk about 3 key things. I want to talk about when should you use third-party model APIs. The second thing is when should you not use them, aka when is it a good moment to fine-tune your models. And then I also want to share some learnings from our deployments of LLMs at the current stage. So first, let's talk about some model APIs. So I just tried to summarize what happened at Digits in terms of LLMs over the last 12 months. So a little bit over a year ago, we released our first generative machine learning model. This was before GPT-4 and those model APIs. We fine-tuned a T5 model. And that solved a very specific use case in our product. And it was highly regarded by the users. They were super excited and ecstatic about wow, that writes my messages to my clients. In December, we went to a conference at the same time while ChatGPT came out. We went to an accounting conference, and our CEO was asking the audience, was hey, have you heard about ChatGPT? Everybody's talking about these days about ChatGPT. Nobody in the audience has heard about it at that time. Then later on in March, GPT-4 comes out. We started using the API. We also started fine-tuning Llama models or open source models, and we were sort of stuck in this realm of damn it, we can't get any hardware. So we went back and forth between integrating with a third party or fine-tuning our own LLMs. But at the same time, the user acceptance has shifted drastically. So people understood all of a sudden what machine learning is, what AI is. And a good example is we went to another accountant conference in June, and my CEO asked the exact same question. It was have you heard about GPT-4? And everybody in the room raised their hand. So it was pretty exciting to see. So in terms of insights of our model APIs, we do consume them for some tasks. And so the interesting thing is machine learning got much closer to the domain experts through those APIs. That's not surprising. Everybody can use those APIs pretty easily. And especially on our team, some software engineers picked up those APIs to integrate their workflows to build new product features, et cetera, et cetera. It's extremely fast in terms of time to market, so that's extremely useful, but it's also not as costly as we had initially anticipated. But at the same time, there's a bunch of downsides. We don't know how those models are being trained. We don't know what the privacy concerns are. Like, if we share the data, what happens with the data itself? Interestingly, we also found out that the first results with those LLMs are always super impressive, but then you figure out over time that those APIs are sometimes they're really good at like hallucinations, and they're really convincing in those hallucinations. And then you shift the engineering effort down the road. You figure out like, oh, the outputs is actually inconsistent, so we have to build all this like engineering around it to work with this inconsistency. So when we take a look at the other side of like the fine-tuned LLMs, then we see the following. You don't have to share the data with a third party. So that's usually great, especially if you work in a regulated industry. And then you have very limited privacy concerns. You do not need to change your terms and conditions. So something you don't need to reach out to your customers. You don't have to go through the Zoom effect where they change the terms and conditions and everybody is like screaming. And you can build intellectual property. So you build the training set, you build models, they basically become in-house IP. When you talk about the fine-tuning, that is a whole different story. So there's a much larger investment than just hooking up with a third-party API. All of a sudden, you're dealing with like, how do we fine-tune those models? How do we get the hardware in place? There was a time in late spring, early summer, where we couldn't get any hardware at all. Price was not a matter, didn't matter. There was simply not enough hardware resources available. We worked with our Google contacts, and they helped us to move our training runs to some completely unrelated part of the world because there were some hardware available. It was not a problem for us, but like it took a while to really find those resources, and maybe for 2-3 weeks we couldn't really train those models. We looked at optimization layers like QLoRa and PEFT, and for the different problems we tried to solve, the performance was not really satisfying. It was really underperforming. So we ended up fine-tuning the entire model, not just the optimization layer. And then I think people should stop talking and comparing OpenAI with open source models. It's simply impossible to outperform GPT-4 or potentially GPT-5, simply because there's a whole team of like hundreds of people like optimizing models, and this is a combination, it's an embedding, an ensemble of different machine learning models, and they heavily focus on latency optimizations and things like that. So when we talk about the deployments, then it's even more interesting. Like it's an expensive deployment. So for example, if you have a model, you can't quantize it for some reason, or you haven't really quantized it, all of a sudden you're spending at least $5,000 for an A100 machine per month. That's a single instance. So now if you want to scale your problem, you go in $5,000 increments per month. And that's really big price shift, so you really need to consider, is that something you want to do or not? When you think about scaling also, you might have the whole setup, and all of a sudden you try to auto-scale your machines, and then all of a sudden you get a message from your hyperscaler saying, sorry, there's currently no hardware available. Well, all this auto-scaling setup doesn't help you in that moment. And when we started working with LLMs, the hyperscalers weren't ready for large language models, and we can talk about this in a second here. However, the interesting thing is that there are amazing developments currently going on. So at the moment, we're testing out a Llama 2 setup on a T4 machine with heavily quantized models. So there's a lot of amazing developments happening. So what are the lessons learned from our side? So when you want to integrate with a model API, try to reach out to the providers, regardless of who that is, if it's Cohere or like Anthropic or OpenAI. Try to get a no data sharing agreement with those third parties, so that your data is excluded from their future retraining of future model versions. At the same time, make sure that you mask all the personal identifiable information beyond like the typical PII things like credit cards and so on, before you submit it to the third-party providers, like mask names, phone numbers, addresses, and things like this, so that the data doesn't leak into their training sets, even though you might have a no data sharing agreement. think about and talk to your customer service folks about potentially updating your terms and conditions. You're exchanging data with a third party, and that is often not compliant with your existing terms and conditions. And then at the same time, heavily monitor your responses from the APIs. Throughout the last couple of months, the performance of those APIs have changed, sometimes to the better, sometimes to the worse. So just monitor this carefully and see if you have to change your prompts or if you have to like fine-tune some things in terms of like prompting, caching, and so on. When we talk about LLMs, as I mentioned, getting the hardware is a big bottleneck. So having a good relationship with your hyperscaler, maybe there's a good sales rep in your region you can reach out to and tell them, hey, we're working on deploying our LLMs here. Can you help us getting some allocated resources? And then keep the training flexible. So during the training phase, you need a lot of resources. So like you want to bundle your GPUs into a cluster, sometimes 8, 16 GPUs. In that moment, you might have to shift regions depending on where the hardware is available at this point in time. The interesting thing when we looked at the deployment, or the training, we found that the costs are sort of like, they're sort of constant. So you can train for 16 hours on a single machine, or you can train on 4 machines for 4 hours. It's basically the same cost. The only time where you need more money is like when you set up your machines. Obviously, when you're idle on 4 machines, that is more costly while you set up your entire environment. So maybe you set it up on a single machine, and then once this works, scale it up to like as many training instances you want. And yeah. And then the big question is like, how do we actually evaluate your machine learning models and your LLMs? That's still up for debate, and I'm happy to discuss that. After the talk, we came up with a metric on our side where we said like, we want to have very high semantic similarity to our example sentences. So let's say our generated vectors would be really close, but we want a high difference in terms of like language diversity. So we want to have a low Levenshtein distance. The model shouldn't memorize sentences. It should be creative and come up with completely different wording for the same phrase over and over. So when we talk about pipelines and deployments, on our side, we have everything orchestrated through TensorFlow Extended, or TFX, and Vertex pipelines. That handles all the fine-tuning of those large language models, like whether it's Llama or Llama 2. But when we started using the Google Vertex endpoints, we discovered that they weren't ready for those large language models. All of a sudden, their model registry was telling us, like, sorry, you can't upload a model bigger than 10 gigabytes. We had to build our workarounds for those types of things. I think these days you still can't upload models greater than 10 gigabytes, but you can store reference, and then you have to do some manual steps to get your model into production. At the same time, we use TorchSurf, and the TorchSurf model archiver also wasn't designed for like large language models, and so we had to do some workarounds. If you're interested in like the specific parts, happy to chat after the talk. And then there's this really important thing which we need to discuss, and regardless of what you use, whether it's an OpenAI or Cohere or like a model API, or you train your own model, it will hallucinate. So there's 3 things we implemented for all our generative AI endpoints or tasks. We do a very sensitive, not safe for work check. And very sensitive means it even fires if you would read the sentence and you wouldn't deem this as totally normal. So we want to be very conservative when it comes to like what goes through those checks. At the same time, we check for patterns. So we had this use case, we worked with a lot of banking transactions, and there is the term POS, point of sales, is often happening in those transactions, so POS and then a certain number. Well, if you have a large language model and it sees POS, it predicts the next token and the next token and the next token. It all of a sudden becomes a possession. And then the next word is like a charge. All of a sudden it talks about like criminal charges, which is clearly not what we want to have or what we want to send to our customers. So we check for those patterns, and then we block them from being visible to the end users, and then continuously monitoring your LLMs. That's really critical. So whether it's like through some data platforms, or whether you pipe this into like your Slack or your Microsoft Teams or whatever to review the outputs. And then interestingly, it's critical to talk about the consumer acceptance. So if you want to decide whether you go with a model API or you want to fine-tune your model API, an LLM, think about what's your risk profile of your customers. So we end up having two customer groups. One customer group is like, they're saying, solve my problem, whatever tool you can use, do it. We have some other customer groups where they're like, oh, my data is that's my holy grail. Don't share it with anybody else. So we interviewed the customers and then figure out like who gets what tool and who gets what platform. But also at the same time, that user understanding is rapidly changing. So while sort of this process trickles through into the general discussions, people adopt to like the risk profile. Initially, we saw concerns, as I mentioned earlier, but now people are like, you can actually solve my problems. And at the beginning, people were talking about like, oh, this is like a job killer. Nowadays, people come to us and say like, actually, this is not a job killer. This is a massive revenue opportunity for me because like I can handle twice as many clients as before, but I can charge them the same amount of money. So that is an interesting viewpoint, and it's not like we're killing jobs here. So survey your customers and then find out what works for you for your implementations. And then another important point is once you know what your customers want, you also have to double check what are the regulations and compliance risks on your side. It sounds very dry and it's legalese, but like, are you working in a regulated industry? Like for example, if you work for the federal government, well, you probably don't have to think about integrating with OpenAI. If you work in fintech, that's a very restricted, very regulated industry, so you probably want to fine-tune your models. Do you have European customers? That might be something to consider. And are there any specific privacy concerns? Do people want to get their data deleted, or et cetera, et cetera? So when we talk about like model APIs versus fine-tuning, the question is like, is it worth it? Is it worth it to go through the hoops of fine-tuning your own LLMs? And I would say, consider a couple questions. I think every use case is sort of unique, but like, here's a couple of things I would try to answer from your point of view. Is like, can you mask sensitive data? If the answer is yes, there might be a good chance to use a model API. Do you need to update your terms and conditions? Is that a big deal for your organization? If the answer is yes, that it is a big deal, maybe think about an LLM. How important are feedback loops to you? So for example, if you go to OpenAI and you get a bad response out of it, how can you actually tweak this so that next time your model or the request performs better? The only variable you have there is the prompt. And probably based on this particular customer, you might not change out the prompt. So if you see those use cases, then fine-tuning an LLM is actually a really good application for you because you can bring those training sets back, fine-tune it with those new examples, and then take it from there. Like if you get more flexibility through those LLMs. And then again, are you working in a regulated industry? So if you have like a lot of compliance questions, then it might be easier to answer them with your own fine-tuned model. So is it easy to host your own internal models? It gets easier by the day. Like the tools we have now, or which came out in the last months, are vastly different from the ones we had in April, May, June. It is still an expensive training, so it's not cheap. You spend like easily a couple $1,000s on like fine-tuning a simple model. And the deployment costs are much, much bigger than the actual training costs. So just consider that. And also that you scale in those multi-thousand-dollar increments. And so when you talk about all these costs, think about it can you even do it with a simpler model? Like for example, the first generative model we used was like a T5 model. You can fine-tune this model pretty easily. It's very cheap. And you can also host it on a CPU instance. So the hosting cost is much, much less than for like a Llama 2 model on an A100. So it's very problem specific. We usually have a problem and then we try it out with different models and see what has the best performance. So a couple things just to conclude. So let's stop comparing OpenAI models with fine-tuned LLMs. I think that's an unfair comparison because like we compare like an ensemble with multiple models with a team of multiple hundred of employees optimizing that versus an open source model, which a small team is fine-tuning in your case. Model APIs are really good if you want to get something fast to the market. The integration is still tricky, but it's much faster than getting all your ML stack into place. You do have a loss of intellectual property. If you pipe your data to OpenAI, that cannot be considered as your IP in this case. But if that's okay with you, if you just have to, if you want to solve a particular non-business related problem, then go for it. It has much lower initial costs. So you get something up and running. Some folks say like if you have a high traffic application, the costs actually are then roughly the same between hosting an LLM and OpenAI. And the interesting thing is if you fine-tune your own model, the long-term costs will be, could potentially be, or the long-term benefits are that you have shorter prompts. And that also means that shorter prompts is lower latency and you might get faster response times that way. Okay, so while we have a few more minutes, just a couple of things I'm personally super excited about. With our own internal LLMs and things we're gonna do we currently have cooking, is like, we observed that when we fine-tuned our own LLMs, it was able to recommend missing categories from a chart of accounts. A chart of accounts is basically a list of categories which each company brings in and has in their accounting books. And so we trained an LLM to predict those categories for us. And at some point it started like predicting categories which weren't in this list we asked to predict it for. And that was interesting. When we looked at the failure cases, they actually turned out to be not failure cases. They were like, wait a second, there's actually the category missing, which is a super astonishing case that the model sort of picked up on that. And also another interesting case which we recently developed was like using an LLM to predict a category, but then also explain that category to me. Why did you pick that category? So that is a really good use case for an explainability case. Sometimes when I reviewed the model, I found like some use cases where I felt like I didn't even see that particular detail in the transaction, but the model picked up on that and then explained it back to me why it made that decision. So that was pretty cool. And then something we're really excited about is when you have your own LLMs or you use model APIs, you can then build your own AI agents, and that will replace a lot of automation in terms of workflows and help people with like bringing into those tools into their stack. And then the last but not least, the interesting thing what I'm really hoping for is like better QLoRa support. So for example, you can host one large machine learning model. Maybe that's getting hosted on a A100 machine, which is very expensive. And then you host the individual layers for specific tasks on smaller machines. And that can be pretty cost efficient if you have like 8, 10, 12 different tasks, and they reference all the big machine learning model on the one A100. So excited to see what's happening in the next couple months in those realms. And with that, I think there are a couple minutes left for questions. Thank you.
All right, so if anyone has any questions, please feel free to put your hand up, and our mic runner will run around and hopefully stick that mic in your hand.
Hi. What do you think about the synthetic data? What do you think about the synthetic data for training the fine-tuned model or something?
It's an interesting question. We have talked about this for a while now. So I think that changed quite drastically with like, maybe you can use a model API and ask it to come up with build a training set for you. You have to be careful. I don't think that's fully compliant with the terms and conditions of those API providers.
Mm-hmm. Okay, thank you.
Hi, great presentation. My question is regarding RAG architectures. Before we talk about fine-tuning the LLMs, what do you think about RAG? From your experience, how do you think the generalization with RAG makes sense for different businesses before they think about getting an external API or fine-tuning their own models?
I think the RAG applications are really interesting, especially if you have the team to support that. Like this morning, the speaker gave like an overview about the infrastructure. You have more belts and whistles you need to maintain, and so that brings in more complexity in terms of like your vector store, the right embeddings. We built something a couple of years ago at Digits where we have our own embeddings models. So every transaction gets fully embedded. We have custom embedding models because we need to support very small dimensions just for very fast lookups. And that's quite the engineering task to keep this updated and maintained.
Hello, so I have a question real quick about Llama 2. You mentioned you have it in production. Can you talk a little bit about, without giving company secrets, like what that ecosystem looks like? Do you have like a batch type of inference pipeline in front of it? Like what does the scaling look like? And the hardware in which you're running it?
So the inference time is not like definitely not in the millisecond range. That is in the second range, sadly. It depends on how many tokens we generate and things like this. We host an online endpoint, but that online endpoint is consumed by batch pipelines. So we just keep this running so that it can be consumed by any batch pipeline running in that process. Yeah.
Could you elaborate on the fine-tuned embedding models you have, or the custom embedding models you have, and how you train them? If not, that's okay.
That gets a little bit to the core of what we do. I can say so much that the team has like many years of experience of building embedding models. And the key thing is to have very small dimensions to just make the lookup really fast.
A small number of dimensions?
Yes.
Okay.
So you have an index with millions and millions of transactions, and therefore we need to keep the dimensionality really small, so that the ANN lookup is still fast. Yeah.
Thank you.
Yeah.
This morning. So hi, I believe you mentioned earlier that you're in GCP now and using Vertex. Have you considered looking at other cloud providers? And is there any issues with migration of your infrastructure, your data, and why that may be a limiting factor to move from one cloud to another in order to get access to the compute you need or run your business?
I don't think we have considered moving. We have a good experience with Google Cloud. They're very supportive. It's a great ecosystem. It's probably possible to move. Yeah, the thing is when we evaluate third parties, it's often the data has to leave the VPC, and that's a harder problem for a fintech company because all of a sudden we promise our customers that we stay in control of that data. Yeah.
Questions. Thank you very much, Hans.
Thank you.
All right.